Hello, everyone. Today, we will discuss Section 5 of Chapter 4, PoS-based consensus algorithms. PoS consensus algorithms were primarily designed to address the flaws of PoW. As we have analyzed before, PoW is a very resource-intensive algorithm. In fact, in 2017, Bitcoin's energy consumption exceeded the annual electricity consumption of 159 countries. The excessive consumption of resources is clearly not conducive to large-scale application. In addition, the proof-of-work mechanism also faces issues such as the 51% attack, leading to security risks. As a result, many blockchain systems have adopted proof-of-stake PoS as an alternative. The principle of PoS is similar to the concept of equity ownership in the real world. The more shares you own, the stronger your influence, and the greater the probability of being selected to participate in block generation. Therefore, PoS doesn't require the computational power consumption like PoW does, which means it avoids wasting resources. At the same time, PoS reduces the time required to reach consensus, thus improving efficiency. Proof of stake is a consensus protocol invented by two scholars and was first implemented in Peercoin in 2012. In a blockchain based on proof of stake, token owners are the ones who influence the network, generate new blocks, and ensure the system's security. Nodes do not need to solve computational problems. The system combines BO, balance, or stake, and a degree of randomness. Nodes with higher BO, more stake, are more likely to be selected as block producers than nodes with lower BO. In Peercoin's PoS proof formula, the rule is proof hash, coin age * target value. The proof hash corresponds to the hash value, and the target value is used to measure the difficulty of PoS mining. The target value is inversely proportional to the difficulty. The higher the target value, the lower the difficulty, and vice versa. In Peercoin's protocol, there are additional rules to prevent high coin age nodes from dominating the block generation process. First, the coin age in your wallet must be at least 30 days before you can participate in the election to produce new blocks. Once a new block is generated, a transaction is automatically created to return tokens to the node that produced the block. Finally, the probability of a node finding a new block reaches its maximum after 90 days. Now let's introduce another improved mechanism called DPoS, Delegated Proof of Stake, also known as the Delegated Stake-Based Proof Mechanism. DPoS is similar to the Board of Directors system in companies. Under the DPoS consensus mechanism, a certain number of representatives are elected to produce blocks. These representatives are elected by token holders, who vote based on the tokens they own. DPoS consists of two parts. First, stakeholders vote for new delegates, with the number of votes proportional to the amount of stake. A certain number of delegates are then selected. Then, the delegates take turns producing blocks with equal rights. In DPoS, at any time, when a node sees a valid longest chain, it will switch from the current fork to the longest chain, thereby making the longest chain grow longer. The advantages of DPoS are its lower energy consumption and faster confirmation speeds. Each block takes about 10 seconds to produce, and a transaction takes about 1 minute to confirm. A full cycle of 101 blocks only takes about 16 minutes. Comparing this to Bitcoin, Bitcoin produces one block every 10 minutes, and a transaction takes about 60 minutes to complete, since it requires 6 blocks. For Peercoin's PoS mechanism, confirming a transaction also takes about an hour. However, DPoS also has some issues. First, there is a low level of enthusiasm for voting among nodes. Second, it is difficult to handle malicious nodes. Furthermore, because DPoS achieves consensus by electing delegates, it introduces a significant centralization problem. Now, we've discussed both POW and PoS consensus algorithms. Let's analyze their advantages and disadvantages. Advantages of POW. 1. High security. Since POW requires solving complex mathematical problems, an attacker needs to control most of the network's computational power to successfully attack the network. 2. Higher decentralization. Just like Bitcoin, why do so many people trust it? POW is highly decentralized. People trust Bitcoin because it does not rely on any third-party institutions and everyone can participate in mining. 3. Mature and widely adopted. With Bitcoin's global development, POW has become a well-known consensus algorithm. However, POW has several significant drawbacks. 1. High energy consumption. POW is resource-intensive, meaning it consumes a lot of computational power and electricity. 2. High hardware requirements. Mining requires specialized, high-performance GPUs, so regular computers cannot participate. This makes it less friendly to general users. 3. Potential for 51% attacks. If a single entity controls more than 50% of the network's computing power, it could potentially attack the network. Advantages of PoS. PoS's advantages are essentially the opposite of POW's drawbacks. 1. High energy efficiency. PoS does not require massive computational power, as its purpose is not to solve a mathematical problem, but to use the concept of equity ownership. 2. Decentralization. Like POW, PoS can also achieve decentralization. 3. Lower entry barriers. Compared to POW, PoS has a much lower entry threshold. You don't need professional equipment. Even a regular computer can participate. However, PoS also has some disadvantages. 1. Lower security. Since PoS doesn't use the same computational challenges, such as hash functions, to achieve consensus, its security is lower compared to POW. 2. Wealth concentration. In a proof-of-stake system, if a single entity controls a large portion of the tokens, they can gain more rights and rewards, leading to a concentration of wealth. 3. Potential issues with DPoS. Since DPoS is relatively new compared to POW, it may also have some unknown potential issues. Alright, everyone, we've now finished all 5 sections of Chapter 4. Let's do a brief summary. In this chapter, we primarily discussed consensus mechanisms. Consensus mechanisms are the foundation of blockchain technology. They solve the problem of how nodes can reach agreement on a public ledger in a distributed and trustless environment. The consensus mechanism also determines the blockchain's security, scalability, and degree of decentralization. In this chapter, we introduced several classic consensus algorithms, including CFT consensus, BFT consensus, POW consensus, and PoS consensus. After the class, please review carefully and master these for consensus algorithms. That's all for today's lesson. Thank you, everyone.